I'm going to show you guys how to solve exponential equations without using logs. The goal is to get the base equal to the same base on the other side of the equation. So I have 7 to the 2x power equals 7 to the x plus 3 power. So since these bases are the same, these base numbers, we are going to cross them out, and you just simply take the exponents or the powers and you use them as your new equation. So we want to get x by itself. We're going to subtract x to the other side. That leaves us with x equals 3. Now if I take this value of x equals 3 and I plug it back up here into our exponents, that would be 7 to the 2 times 3 power, which would be 6. And if I take this 3 here and I plug it in right here, that would be 7 to the 3 plus 3 power, which would also be 6. So 7 to the 6 power is 7 to the 6 power. I'm 100% correct. But what happens if the bases aren't the same, like in this example here? So what we want to do is we want to try to create a base of 6 over here using 36. Well, how do I turn 6 into 36? Well, that's simple. You just take it to the second power. 6 to the second power is 36. Now that I have these bases that are the same, I can use my exponents and create a new equation. 2x plus 2 equals 2. We'll solve this here. X is on the left, so let's move our numbers over to the right by doing opposites. So we have 2x equals 0, and then we're going to divide by 2 because the opposite of multiplying is to divide, and my answer is x equals 0. All right, let's look at another example. All right, the goal is to get the same base number here, so I want to get a 3 over here. So I need to take 27 and turn it into a base of 3. So 3 times 3 is 9 times 3 is 27. So I know 3 to the third power is 27. But what do you do with this exponent here that we have in white? Well, you're going to take that and you're going to multiply it. So now that becomes 3 times 3, which is, that's actually 3 to the 9th power. Now that my bases are the same, I can cross them out, and we create our new equation here. 5x equals, and we're using 9, right? So now we're going to just divide by 5, and I'm just going to leave it as a fraction here, 9 over 5. Let's look at one more example here. All right. Remember, the goal is to get the bases the same, so I need some 9s, right? 9 to the second power is 81, but I have to multiply that x with that. So I'm using 9 to the 2x power. Since my bases are the same, I can cross the bases out and just simply use my exponents. And since I have x's on both sides, the number is right here. So since the number is on the left, we are going to move x's to the other side. So let's move 3x by subtracting it. And I can apply the -1 rule here. And so I have an x value equal to 1. Now there is another way of solving these, and I'm going to use the calculator method to solve this example that we have right here. What you can do is you can open up your calculator. I'm going to use the TI-nSpire here, and I'm going to go to New Graphs. And what I'm going to do is type in the left side of that equation, and I'm going to put that in F1. That was 9 raised to the 3x minus 1 power, and I press enter. I don't care what the shape is. All I care about is I'm going to look for an intersection and look for that x value of it. We're going to add another graph. This time we're going to type in the right side of the equation, which was 81 to the x power, right? And I'm looking at where these intersect. So I'm going to analyze graph and calculate an intersection. And you can see right here that they intersect at 1, 81. I only want the x value. The x value of that intersection is 1. And if you go back to our answer choice right here, it was 1.